Alrighty, so welcome everybody to the new unit of quadratic equations, and let's just dive right into it. So, let's firstly start with let's write a title of quadratic equations. Quadratic equations. Or I would say also functions. And we can put it into a very nice, let's go with blue. So I'm going to put it into a nice blue box right here. All right, so starting from the very definition, we're going to start from the standard form of how I like to call it, or how it's called, the standard form of the quadratic equation. How does this look like? So we remember of how a linear function looks like. So let me just write a linear function right here. So for example, we could have the coefficient of 5, so 5x to the power of 1 plus 3. Yeah, so we see that it is to the power of 1. Now, in the world of quadratics, the exponent, this is the exponent. The largest exponent is 2. Yeah, so we can at least write down a very simple definition, and that a quadratic equation or quadratic function is a polynomial. More on that later. Where the largest exponent is 2. So let's write down the standard form of of just what a quadratic equation or function looks like. Let's go. So we have a very nice y of x. So this is our function, and it's going to have 3 terms. Okay, so let me go already put the blue. There is going to be a x squared, there's going to be an x, and there's also going to be just a number. Now let me decide on let me decide on a number. So this is a green coefficient a. This will be b, a blue coefficient. And let's go with a yellow c. So these are coefficients. Coefficients are simply any real numbers. So all of these 3 are simply coefficients. So a, b, and c. The green one is called the quadratic coefficient. The blue one is called a linear coefficient. And the last one is simply a constant term. And all of these 3 coefficients are simply real numbers. So put it mathematically, a, b, and c belong to all real numbers. Okay, so where do we begin? Where do we begin understanding of how to draw this, and what is the discriminant? What are the roots? What are these things? So let's unpack it one by one, and I really recommend to put a nice box right here. Okay. So let's start with a little bit of more theory, maybe unfortunately, but the theory helps you understand the entire idea behind mathematics and behind, honestly, any skill. Okay, so for us to be able to draw a quadratic function, so let me put a coordinate system. Okay. We will need to find or calculate exactly 3 points. Okay. So let me draw first of all one. Actually, let me go like this. I'll draw a random quadratic function. Okay. So this is a green one. Well, let's call it y1 of x, and let me draw a red one, which is located, let's say just here, simply here, and this is y of 2x. So the first important thing is the shape. So understanding the shape. Now y1, I am 100% certain that going back to our quadratic equation, the universal one. Let me just check the colors that I used. So I used green, blue, and yellow. So I'm going with, what did I say? Green, blue, and yellow. Okay. So green, blue, and yellow. Okay. X squared, x plus c. How do I know which shape is which? If it's a, and yes, it is. Simply, we can view this as this is a smiley face, so upside up, or if it's an upside down or a frown face. Now, how do I know which one is which? And the first rule is extremely simple, is that we look at this a value at the quadratic one. It is the green shape, so if it's a positive number, if it's a positive number, then we draw it this way. If it's a negative number, so a is smaller than 0, then we have a frown face. That's the first rule. We can call this the shape rule. Not very scientific, I just made this name up, but let's call this the shape rule. So again, a, if it's larger than 0, right here, it could be any number. So for example, if we would find ourselves to be drawing, let's go with just a quick example. Let's say it's 2x squared plus 5x minus 7. And the other one is, let's go with minus, I'm going to go crazy, minus 7, big number. Minus 7 plus 6 x minus 5. Now, from drop of a hat, you're able to understand which shape it's going to be. All you need to know is that, hey, well, let me at least write down what is A, B, and C. So, in our problem, our A is positive 2. Our B is positive 5. And our c, now be very careful with this, is a negative number. You cannot ignore that there's a minus. The minus is important. If you're minus 5 euros, it's not the same as if you're plus 5 euros. Minus 7. Going into the other problem, let's go with again with a nice green. It's a minus 7. A is minus 7. B is plus 6. And the last one, I think you got it. It's simply minus 5. So only looking by the A value, so we see A right here is larger than 0. This is, and I used the red color. I should have used the green color. A is larger than 0. So it's a happy face. It's a happy face. So positive. Going here. Is it minus 7? Is minus 7 smaller than 0? Of course. It's less than nothing. You actually owe somebody some money. Therefore it's red. Therefore it's red, and it's a frown face right here. And it's a frown face. Okay, so we have the shapes down. And we're continuing on to understanding to the roots. Okay, so let's just put quadratic roots. Okay, so first of all, what is a root? No, I don't mean the plant. I don't mean the plant. A root in mathematics is very often, especially in high school mathematics. Let me draw any kind of. Let's draw. I'm going to draw 3 different. I'm gonna draw one in blue. So I'm gonna put one here. So let's call this y1 of x. I'm gonna draw one in red. Right here. y2 of x. And let me draw a third one. y3 of x. Perfect. Okay, so what are roots? Now, the root of a quadratic function, I'm gonna write in blue, okay? Roots of a, or any kind of function, but let's go with quadratic function, is where, well, this is just from my head, the function intersects the x-axis. This was a more complicated definition, or a very simple definition, is simply that we look at the line or the values when the function equals to 0. So we are looking at the values. So what values of x, is the function equal to 0? In terms of the blue one, okay? So do we have a point where the value is 0? The answer is no. We don't have. The lowest point is right here. Yeah, the lowest point is right here. This is the smallest point, and we see that it could be a 5. It's definitely not a 0. So in the blue function, there are no roots. So in y of x, it has no roots. Let's go to the red one. I think the red one we already see only one point that touches the x-axis, which is right here. This is the point. This is, of course, y equals 0. So y equals 0 is this line. I'm going to draw it in yellow. So this is y equals 0. This is y equals 0. And the point sorry about that. The green function, or pardon me, the red function right here, has one root. One root. What is a root? Again, it's the value of x that the function, when we plug it in the function, and this is 2, is equal to 0. So we have a point. We have a point of x. This is x. Following with the last one, with our green function, is that we have two of these points. One here and one here. Two roots. How do we find them? How do we find these points? Because again, we don't know how this function looks like when we get, for example, our quadratic equation. So let's find these points. Let's find these points. How do we do that? And I think that's going to go into the next video.